if you observe till the questions whatever we have done over here, it all lies as A is equal to BQ plus R. This is all the main thing you have to learn, and then it's clear. Next question. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march the same number of columns. What is the maximum number of columns in which they can march? Here they are telling that there is a army contingent and there is a army band. There are two sorts of people over here, army contingent and army band. Okay, army contingent is of 616 members and army band is 32 members. All they are asking is, in a two groups, equal number of people should be there, and what is the number of columns they can make is what they are asking. Here, yesterday only I said you that once you see the word maximum, you can just tell that you have to find HCF between 616 and 32. Okay, we'll solve this. Here the bigger number is A, next smaller number is B, and the format is A is using Euclid's division algorithm. A is equal to BQ plus R. Okay, here you have already written that A is 616 and B is 32. So for us to substitute, 616 is equal to 32 into some divisor plus some remainder you have to find. Okay, so here 616 divided by 32. 32 twice it exceeds, so we'll just take one time only. So 32 here 11, over here 5, and then 9, 2. You have to carry this down. 32 how many times is 296 is what we have to find. 32 10 times is 320. So we'll calculate 19 times. Yeah, we'll just, sorry, 9 times is what I try to tell. 32 9 times 18. 288 is what you'll get. 32 9 times is 288. 10 times will become 320, and which exceeds what we have to find. So 32 9 times is 288. 288. I don't have space over here. I'll continue. Here 16, over here 8, 8. Okay, we'll find 8 is the remainder. 32 into 19 times plus the remainder is 8. Okay, so we haven't got 0 yet, so we'll continue the same. 32 is equal to 8 into how many times? 8 fours is 32. There's no remainder, so 0. We've already got 0, so let's just stop it over here. So HCF of 616 and 32 is 8. So if you read the statement problem, all they're asking is what is the maximum number of columns. Hence the maximum number of columns, therefore maximum number of columns in which they can march is 8. You need not freak out that it is a statement problem. See, only when you can see this word maximum, you can tell that all you have to find is the HCF between 616 and 32. So using Euclid's division algorithm, the first step, and then you shouldn't stop until you get 0, and then write a statement that maximum number of columns in which they can match is 8. Okay, next question. Use Euclid's division lemma. Lemma and algorithm both are same, that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, here they've given some hint. Let's just skip that hint part because the same hint only is the solution part. Let me read it for you. Let x be of any positive integer, then it is of the form 3q plus 1, 3q plus 2. Now square each of this and show that it can be rewritten in the form 3m or 3m plus 1. All that they're trying to tell you is if you find anything in the brackets, you consider that as m. And then square it, and that is what you are going to get. We'll solve this. What should we consider b as? In the previous question, to get 4q plus 1, we considered b as 4. Here in previous second question, to get 6q plus 1, we considered b as 6. Now what? For 3m or 3m plus 1, it is pretty easy. B is equal to 3. Looking only, you can just tell that b is equal to 3. So we'll consider the same and write that. What should we consider b as? B is equal to 3. As soon as you write b is equal to 3, something else it should strike, that is r lies between 0 and 3. What are the values r can take? R can take r is equal to 0, r is equal to 1, r is equal to 2, r is equal to 3. No, it cannot take r is equal to 3 because r should be less than 3. Okay, we will just solve all these cases, that is case 1, case 2, case 3. Case 1, when r is equal to 0, b is equal to 3. What is Euclid's division algorithm? A is equal to bq plus r. So a is a, b is 3, q plus 0. A is equal to 3q. So what have they ever asked over here? What is the square? So we have to write square on both sides. So once we have got this, we'll consider this 3 into q. Q let's just take as, let q be considered as m. Okay, so this becomes 3m. So square on both sides. Squaring on both sides, what you'll get? This you have to square. A square is equal to 3m square. Okay. We'll get a square is equal to 3m square. All we have to get is a square is equal to 3m. Here in the place of, you have to square it over here only. That is, here when you square this, you'll get a square is equal to 3q square, 3q the whole square. This becomes a square is equal to 3 square is 9 and q square is q square. Okay, so we have to consider this whole thing as m. We'll take 3 as common. Before that, 3 q square. This whole 3q square is now considered as m. A square is equal to 3m. If you read the question, square of any positive integer. Here the square of a square should be 3m or 3m plus 1. We've already got this 3m. Here this thing is for your reference. If you do this, you'll not end up that answer. Here you have to do 3m is what you'll get. 3m square will not become 3m. So what you have to consider is here only in this step only you have to square on the both sides. So a square is equal to 3q the whole square. A square becomes 9 into q square. You can take 3 as common, 3q square. The whole 3q square is considered as m. And here a square is equal to 3m. Okay, one part is done. We have to do the next case. Case 2. R is equal to 1, B is equal to 3. Okay, so A is equal to 3q plus 1. Now we have to square. Square on both sides. A square is equal to 3q plus 1 the whole square. This is a form a plus b the whole square. A plus b the whole square formula you have to substitute. A plus b the whole square is a square plus b square plus 2ab. You have to substitute. Here the value of a is 3q and the value of b is 1. The value of a is 3q and the value of b is 1, and all you have to do is substitute in this formula. We'll substitute the same. A square plus a square plus b square plus 2 into a into b. See this. This is a square, this is a, this is b, this is 2 into a into b. All that I have done is substitute in the formula a square plus b square plus 2ab. We will continue the same. 9q square plus 1 plus 3 2s is 6q. We will write this 1 on the other side because we want in this format. What is the format we need? 3m plus 1. 1 is in the right hand side. So we'll consider 1 in the next hand side. So here we'll rewrite the same. Again we can take this as common. What common do we need? 3 common we need. So 3 times is common plus 2q plus 1. Here we can take this whole thing is m. We'll write the same. M is considered see, this whole thing is considered as m. So we can rewrite this as 3m plus 1. See, what did we even want over here? See, 3m plus 1 is what we had required. Here also we got 3m plus 1. This is the whole process you have to consider. Here you also have r is equal to 2. You need not solve this because already first case also is solved and case 2 is also solved. So this is how it stops over here. And this is for 5 marks. Okay, this is how you have to solve.